One-to-one functions. For a relation or mapping to be a one-to-one function, it has firstly to be a function. Each input value for a function may only give one output value. This is easy to check if we can produce a sketch of the function as we apply the vertical line test. To qualify as a function, any vertical line must cut the graph at most once. So it can either not cut it at all, so it's cutting it 0 times, or once. As soon as it cuts twice, it fails the vertical line test. So it's okay for the vertical line to cut the graph once, or not at all, but if any vertical line cuts twice, then it is not a function. So let's look at these three. Let's consider this vertical line, and let's sweep it across. You should see as it sweeps across that it cuts once. It looks like it's cutting not at all over here, but think about the continuing trend of the graph, and the same on this end. Let's look at the middle one. Sweep across, and again it cuts at most once. So both of these two are functions. But if we look at this third one, we can see here that it cuts twice. And that means that we have a single input value, or x value, that's giving rise to two different values in the range. So, in summary, here we have function, function, not a function. Once we have established a function, we need to decide whether it is a one-to-one function or a many-to-one function. To do this, we apply the horizontal line test. So to decide whether or not we have a function, we use the vertical line test. To decide whether it's one-to-one or many-to-one, once we know it is a function, we apply the horizontal line test. If any horizontal line cuts the graph more than once, the function is many-to-one. So for a one-to-one function, any horizontal line will cut the graph at most once. So let's look at these three. So here we have a horizontal line. If we sweep it up, we can see in actual fact that at this point here it cuts 3 times. So that one is a many-to-one function. We have 3 different values of x, 3 different values in the domain that are giving us the same value in the range. If we look at this graph here, once again, we can see here that it cuts here and here. So this one is many-to-one. It doesn't matter that when it was down here, it didn't cut at all. If it's not cutting at all at that stage, it's satisfying the horizontal line test. Then for the third one, it is going to cut here. Think about the continuing trend, so it would cut somewhere over here. So it's cutting once at the moment, and if we sweep it up, it always cuts once and only once. So this one is one-to-one. If it is not possible or convenient to graph the function, then you can use the following condition to prove if it is one-to-one. A one-to-one function satisfies the condition that if x is not equal to y, then f of x is not equal to f of y. So if we consider the domain here and the range over here, if we have an input value here, x, and another input value here, which we'll call y, then over here we have f of x, which is where x maps to when we apply the function f, and we have f of y, where y maps to. So x is not equal to y, which is why they're two different points, and then f of x is not equal to f of y. We could also use the contrapositive that if f of x is not equal to f of y, then x is not equal to y, and that's just thinking about this backwards. It's worth noting that all you need is one counterexample to show it's not one-to-one. So if we had a value here and a value here, but we could show that those both gave rise to the same value over here, then immediately we'd have a many-to-one function.